Ah, dangerous chat crew. Dangerous chat crew. Pickle Squad. I don't know what to say about Pickle Squad. Okay. How many lines of code? It is that number right there. or all three of these numbers added together. It depends on how you count. Depends on how you count. Why did I just make a release build? Gee, look at that. A debug compiler making a release build in LLVM takes fucking forever, but... Oh, it's under the face cam. Well, now it's not, though. Now it's up here. You liar. Like, if this were discourse, quote unquote discourse on Twitter these days, I would say, you liar. It's not under the face cam. It's right here. It's a third of the way down the screen. Are you an idiot? Why are you misleading people with fake information that this number is under the face cam? You're a hateful person for saying that this number is under the face cam. That's what people would say on Twitter. I do not condone this manner of discourse. Discourse is too polite a word for that. I'm going to get some more delicious golden monkey tea. Back in a second. Okay. Well, the 10 line savings actually happened just before the stream, but it's since the last stream, so, you know. All right, so we're going to run the pickle sector tests on this. So what I'm doing right now is I'm continuing the polymorphism cleanup, which could get involved because I'm trying to remove some old stuff about the way things were done, and it could be gnarly, could be easy, who knows? Who knows? Great. So what this means is I could get rid of whatever this function was called. What was it called? It was called isBoundPolyVariable. Whoops. I'm in the wrong code base. isBoundPolyVariable. Boom. Great. Guess what that means? Boom. Yeah, let's just commit that. So what I'm trying to do now, there's this thing called defines constants block entry. You can see it's used a fair bit. And we want to get rid of this data member off this type definition and in fact, simplify it out. And all this code that uses it should do something else. Like, for example, ask for example, ask is unbound constants block binding, for example. Right? And that hopefully will be the same thing. So maybe phase one is to switch all this over so that we don't ever look at that member directly. Now, this actually is a different thing. So I'm going to change it piecemeal and sort of use it as an opportunity to revisit the code that's checking this variable because some of it could be old and quite questionable. And we'll see. So I want to kind of replace it with this, but if that's kind of not working, then at least I could replace it with some other function that just checks this data member. And that's a cosmetic change, but we get all that working. And then we check it in, and then we change the implementation of that, right? But hopefully I can just use this most of those places. Okay. What defines constants block entry is the name of it. And so eventually we're going to want to get rid of this function because basically I'm trying to get rid of this whole convention. Okay, so last time you saw, or maybe it was even the time before last time, we did a switch over on the way we were doing polymorphism to a different set of matching routines. The new set of matching routines does not use this data structure for matching anymore. The whole reason we were setting up this piece of the syntax tree, it's not even really the syntax tree, but this piece of something kind of between the syntax tree and the type tree, the way it was so that that old matching code could work. And now that we no longer use these for that purpose, we don't really need them in the design of the compiler anymore. However, other people now want to know what is this thing in order to do various stuff with it. So we're changing that. We're changing that. Okay. So I'm just going to maybe go a file at a time. We'll start with a small one like sizing. Okay, so in the header file, we're asserting that it's not a constants block entry. And this is in get alignment. Okay, so the new thing doesn't have a type attached, so this is kind of meaningless. There's no such type, so we can just delete that one. I want my golden monkey. Chadley sector. Okay. that one is easy clap. So now over here, same thing. This only made sense in the context of when there was a type representation for this thing. Does not make sense anymore. Okay. How about matching? Because here there's only, I'm just looking for places where there's only 2 or 3 lines. This is maybe going to be a thing. So let's see. Attempt to match a unary literal with a polymorphic type. This is a check that we still need to perform that we actually may not be performing. So in our test coverage for the compiler, we have relatively much test coverage on like correctly working programs that use features that are supposed to work. We don't necessarily have that much test coverage. In fact, we definitely don't of like make sure an error happens. And so we do have and that's because just our test suite didn't used to really do that, but now it does. So there are sometimes regressions, or there used to be maybe more, where you would make errors and then the compiler would stop detecting them as I changed things because we weren't testing for them, right? So I actually suspect that this may not be working right now. So here's what I'm going to do. I'm going to actually punt on this. Let's do all the easy ones like the asserts and stuff and get the volume of this down. Then we'll check that in, and that's a low risk check-in, right? Because we're going to do the easy ones and get rid of the majority of source code change. Because if like, you know, things go wrong and we need to like revert or partial revert, it's just cleaner to get to a certain point where there's less stuff going on. Let me look at this one. Okay, this is I believe not going to do anything. We'll leave this for now, but I think this will be an easy removal later when we get rid of this. Let's just look for more of the like things that we just remove or that are a direct translation. I'll just click on through here. So here, this is a, okay, this does have a translate. Let me go to an editor. Okay, so this one, even though, like I just said, oh, it doesn't make sense to test the type definition, but what does make sense is because this came from a declaration and we have the declaration handy, so I can say is unbound constants block entry unbound, or sorry, constants block decal. Because this thing came from that thing. And let's just sweep pickle sector now. Really? Constants block binding. Is unbound binding. That's a little bit of a weird name. Let's replace that everywhere. Okay, so we're going to recompile. We're going to sweep pickle sector. And then we will go forward. Okay, now we at least don't fill the whole window with these, so we're making progress. Um, I don't want to change anything yet again, but we'll look at this next one. While the sweep is ongoing. Okay, so that finished successfully. All right, pickle sector is clear. Now, here we're asserting, right? So like, even if we remove this, so if the identifier, yeah, I don't even think this is worth. Wait, what are we even doing? So if we get a polyuse, this is sus. Investigate. I don't want to do that right now because it's not the business that we're in. So again, here we have you know, we have a translation because we got this from looking up this. Yeah. Okay, now of course, this is a travesty. So scope entry is a pain in my butt. Okay. Now what? Now what? How about going to the next file? Dwarf debug info. And here again, this may actually cause us okay, so we have to look to see if we call into here. By the time we get here, we just have a type and there's no such type for this anymore. So actually write type info comes from write type info. Now, I guess we don't write constants blocks of structs ever. Oh, we would do this for type info. Here we go. Yeah. Okay. When we do, keep in mind that unbound entries, well, no, you can't have unbound entries in runtime code anyway. So my theory is that doesn't matter. All right. Right, let's research. There we go. Interp. Okay, this is for printing out types. So I think we just delete this. Because again, there's no such type. It's not a type. And then LVM. Okay, this again, we wouldn't have a type. This is the equivalent. You can see it's basically the same function as was in the dwarf debug info. It just, you know, they're very parallel in structure. Here, add one parameter helper. I don't know, WTF. Oh, this is when passing things. So this is a runtime value thing, so it doesn't apply. And then this one is debug type from defen. Okay. And then, oh, I guess we got them all. Okay. So we're going to sweep pickle sector again, and then maybe we'll just check in because we did a big search and replace and stuff like that. Oh no, I did the wrong scan in the wrong location. What do I think about YouTube hiding the dislike counter? I think we have so many huge problems, and that's such a small one that I kind of don't care. Honestly. Okay. Pickle sector is clear. 84617 is the new Weissman score. Wow, it actually went down. I thought it might be a break even because of the stuff we added. But there we go. 84617 lines. Commit and minor related to defines constants block entry changeover. Boom. Why do we live in a world where there are more graphics drivers than graphics card vendors? Well, let's not even get started on that. Shall we? How about if we don't talk about that at all? Wouldn't that be fun? If we just don't talk about graphics drivers at all, ever in life. Okay. Oh yeah, okay, so this was the ones that we're going to leave till later. We already discussed that. So we have polymorph and typer and x64 converter. Let's do x64 because this is going to be easy. Where are we? This is add one param. Yeah, that's just not a thing. It's just not even a thing. Okay. Polymorph. Oh, type table. Now this one, I don't even know if this is necessary, but I'm going to say it is for now. And I'm going to say if is unbound constants block entry. Oh, wait, this is for a type. Yeah. Yeah, no. That doesn't exist. But so if we have a constants block, okay, so we put it here where we're at the declaration. And if it's unbound, this is a weird one. This is where it gets confusing because what this code is it's about putting together the data that your program uses at runtime to refer to a type. Now, that said, so types that don't have all their parameters specified, so for example, a struct that takes parameters that are not specified, that is not a valid runtime value, right? Because you have to know everything in order to use it at runtime. However, at compile time, you need to be able to ask type of anything, and we give you back the type. And so I guess, so for any unspecified parameters, we want to claim that they're bound to this polyuse thing, I think. Anyway, specified parameters. Yeah, I don't know. This is a sort of a question about like, what do we put there? What is the most correct or most useful thing to do for people? I mean, I think it's to skip it for now because like pretending that they're bound to some type that acts as a sentinel type to tell you that it's not bound, I think is not preferable to having a very clear thing in the exported information that says, by the way, this thing has parameters that are not bound. Now, the thing is, do we want to waste space for that in the runtime? Yeah, like these are decisions I would rather not make. And so here's what we're going to do. We're going to say, okay, so then we set up the specified parameters, and we never look at constants block again. So that should actually be fine. Let's initiate a scan of pickle sector. Oh my God. That's like one of those games last night when your team is just getting destroyed. WTF. What did I do? Unhandled type in translate type. Because we're changing. Oh. Right, okay. Here's the thing. I took out this other piece of code. And the problem is, I took it out because I'm excited to get rid of these things, but the types are still in the system. Like I was getting rid of this code so we can get rid of the types out of the system. But this thing we can't get rid of yet because it's the thing that recognizes these types that we're still putting into the system, right? Not that. This thing that I deleted. So we have to put this back for a while, but we just have to know we just have to know that's it's handled. We just get rid of that at the end. Good thing we decided to initiate a scan of pickle sector. Okay, there we go. There we go. Uh-oh. Matrix dimensions do not match for addition. Okay. This is some frickin' user code here. This is about the other change. This one. It's causing us not to export some data that actually maybe is legit. This might be something, though, where it's like the user program expecting some old data. Let's verify that this is the problem by commenting this out. I'll run this again. Yep, okay. So let me look at the program. No. So we're saying look up constant integer value. This is easy Sag. I'm trying to think of a reason why this is happening. So what's happening is lookup constant integer value is failing. Well, I mean, you know, we return -1 if we don't find something, or if it's not an integer. I suspect we just don't find the thing. Let's actually see. Yeah, it's -1, not -2, right? So here, if we change this to -33, this is high technology. There we go, -33 by -33. So this is the return we're hitting. We're just not finding it in the specified parameters list. And that is a drag. It maybe just means that this is misfiring. In this case, which would be important to know for some of this other stuff that we're doing. Like the most obvious explanation, which may actually be true but may not, is that this is causing us not to write out something that is actually bound to something, and this function is just saying it's not. That would be a very first order way of doing it. What am I trying to say? Like, you know, sometimes you think, how can a bug happen? And this is the most obvious way. There could be like second order effects, though, where like, because the base type of the struct doesn't get these things written out, it changes the order of some things somewhere, or the size, and that causes something subtle to go wrong somewhere else where somebody expected it the other way. Like, who knows, right? In a complicated program, you never know what's going on. And so the thing is, I almost can't imagine how this could be the problem, is just the straightforward version. That's why my mind went to this place where I'm like, what about these other things? And it's because, well, how could this be? Okay, so Now, the problem is we are going to be putting... All right, here's what we're going to do. We know in this thing that we want this is diagonal matrix. Oh. Oh. Okay, this actually changes things a little bit because this does a using. This does a using. Okay. So it is misfiring, I believe. And the way it is misfiring is as follows. If something has an import link, we're claiming it's an unbound constants block entry. There we go. Okay, there we go. So really, though, we don't want to put this here. And this is where we could have some danger. We want to put it here. Okay. Okay, so now we fix that across the whole program. And that is, you know, that's maybe slightly scary because who the F knows what's going to happen when you do that. But, you know, hopefully it's fine. Okay, that could have been scary. But we are sweeping pickle sector and it looks good. What constitutes a constants block? A constants block is the block where constants are stored. What constants? They are the constants that come from polymorphing or baking a function. So like for if, you know, in C++, the things that you think of as template parameters, those live in a constants block, but there's other ways things can get in there. What's a pickle sector? I mean, if you don't know the history of pickle sector, I can't, you know, nobody can tell you what the matrix is. You have to see it for yourself, you know? Okay, so we're gonna do a little check-in. More small changes. Let's see. I don't know if we went down at all in Weissman score there. In fact, we went up 84620, but we have to be faithful and mark our fluctuations. 84620. Okay. Now we continue. Boom. Okay. Polymorph. Let's get rid of this. So there's a bunch. I'm just going to sweep through and see about how many. All right. Great. This one. Okay. Wow. My claim was, okay, we might need to leave this one in for the same reason that we had to leave the other one in, because we're still generating these. All right, let's see. Wow, I'm super tired from playing video games late last night. Okay. That one's pretty easy. We're just going to leave the old code there. Wait, why are we returning true? Oh, let's copy this. Yeah, so we do not run modify if there are any outstanding parameters. That's something we could think about later. Okay. So here again, we have this source declaration that we're getting this type from. So it makes sense to ask the question if it's an unbound entry, and we could audit later if we actually need to think about that. Let's actually sweep pickle sector with just this so far, because we still even have more to go in this file, but let's be cautious. Lots of good reason to think we're about to break things. Constant in the sense that they are statically known at compile time. Yes. Yes. Oh, pickle sector is having problems. Polymorphic function call failed, but it succeeded. Have I seen Andrew Kelly's talk on Handmade Seattle? No. I mean, you can, yeah, like computers are really fast. You can get them to do a lot of things. How many lines of code a programming language should be able to compile depends on what features it's doing. You know, what's the structure of the compiler, all this stuff. So, yeah, in general, compilers should be much faster than most mainstream compilers that you've seen. There's no question about that. How many times have we cleared pickle sector? Well, you know, yeah, like trouble can arise. Trouble can arise. Yeah, also what does front end mean is like that's a very compiler specific term. What one person calls the front end is not necessarily what someone else calls the front end. But certainly, so parsing is super duper fast, and it's also super duper parallel, right? Because you can parse all your files at the same time. You know, if you have a reasonable programming language. So, you know, like that's pretty easy. Um, in this language, the bottleneck to, like, we consider our type checking to be in the front end. I think most programming languages would. And just our type checker is complicated and does a lot of things. And so it's not really threaded right now. And even if it were, it's like, it's, parts of your program talk to lots of other parts of your program. And so it's more challenging than parsing, right? Because you have actual data dependencies, whereas in parsing, you don't have data dependencies. Only the portion that's embarrassingly parallelizable. Okay, so yeah. I mean, that, it makes sense that, but like throwing around high numbers for easy problems. I mean, nothing is super easy, but like we need to solve the hard problems. And so when people throw around numbers for easy problems, it's like, okay, that's additional information. Cool, right? But like, okay. Okay. We are having problems in pickle sector. And I just want to isolate it down because we made about 3 changes, right? So I want to figure out which of these. So we have one there, one there. Oh, is it literally 2 changes? Oh, no, third. Okay, let's sort of roll it back one by one until we find it. And then once we have that information, we will use it. Pickle sector. Okay, so that probably wasn't the problem because we are still having trouble in pickle sector. Now, both of these... Wait. I thought I no check-in all 3 of them, but maybe not. Okay, let's go up to this one. Oh, I didn't put a no check-in. Okay, we're going to check this. Still have trouble in pickle sector. And maybe that's like, okay, so if it's the first one, although we have fewer problems. Oh, now I'm worried. Now I'm worried because if we have fewer problems, that means some of them are on one of these and some of them are on another one. Which is annoying. Or maybe not. These look similar. Fudge. I don't really know why we are having these problems, but So this is kind of interesting because I'm like, this should be approximately exactly what is unbound constant Sprock entry does anyway. So what we could do, let's verify that pickle sector is clear again. If it's not, then we really have some questions to ask. So anytime you have a thing like this, it's like, hey, I had this one thing and then I tried to make a change and the change broke, but I think it should be the same. Well, here's what you do, especially when you have like a large test corpus like this, right? So we're going to say condition A, which is the old thing. And we're going to go if condition A return true, right? Why are we doing that? Well, so now let's just verify that pickle sector is still clear. Okay? And it should be. But if that's still clear, now I can do this. I could say condition B is this, right? And then assert condition A is equal to condition B, right? It's like, look, for everything in our test corpus, is this equivalent to that? And if not, why not, right? Well, the why not, that's not going to tell us, but then we can investigate. Okay, so if there's an expression, oh shit, guys, I'm a dummy. Wait, no, I'm not. Guys. I've been using this function all along under the assumption that it does what the name of the function says. And it doesn't. This function was buggy, but it was hardly used before. And now we're using it more. And I didn't read the code. Like, I'm pretty sure this always returned false. Lol. Right? Because what was this? Attach def into constants block. Oh no, we set it. Oh. Okay, hold on. Okay, this is, okay, one of the reasons why I was so happy to rewrite this the past couple streams is because the situation as it used to be was very confusing. This is actually, the thing I just said was wrong this whole time. Maybe it's not wrong. Maybe it's right. But here, this thing doesn't detect what I was thinking. This is a different situation. This only happens when we bind something to a definer for somebody else's fucking variable, which I don't think can happen anymore. So I was trying to replace this with something else that didn't have the same meaning. I think if I put assert false in here, maybe it never fires. Maybe it does. Maybe I'm wrong. And then we have to figure out why. But maybe it doesn't. So now we go on a Hail Mary through pickle sector. Oh God, it's firing. It's firing. Now I don't know what to do. Guys, I can't program. Throw in the towel. I'm going to go learn Rust and Unity Game Engine now. It's over. Compiler's a hoax. Everybody knows. Everybody knows it's a hoax. It asserts on line 304. Apply modify directives. Oh, wait, that's a different... I left the other thing in. Holy crap. It's asserting on this. Lol. Okay, wait. There may be hope for pickle sector after all. Maybe it's not a hoax. Oh, no, it's a hoax. Fuck. It's a roller coaster ride of emotion on the stream today. What is happening? It's a disaster. Dogs and cats living together. Assertion false. Line 560. Make struct from proposal. That is in fact this one. So I am confused. By when does this even happen? Ensure any proposal is converted to its target type. Oh, maybe it can happen then. Okay, this is bad, actually. I mean, maybe it's not that bad, but if it's bad, it means I probably won't finish this completely tonight. Because what it means, we need to investigate. We're going to run one of these and look at the data, but if we actually need to do this, it means that maybe we need a different representation for this whole scenario. In which case I wouldn't be able to get rid of this variable tonight because it's still doing that thing. Which of these looks simpler? New polymorphism, poly, test features misc, test regression polycalls, how to 120 polymorphic structs. Let's look at the polymorphic structs. This could just be a bug somewhere else. Like maybe this isn't supposed to be happening, but it is. I'm kind of scared. Collection was modified. Enumeration operation may not execute, everybody. It's my favorite Visual Studio message box. Haven't seen it in months. Bear in mind, you cannot just modify the command line options to your program and hit OK. It doesn't always work. And this is known as the Schirmer-Sperger theorem of computer science, which is that sometimes when you attempt to edit your command line options. You get collection was modified, enumeration option may not execute. And the probability of this is defined by the Riemann hypothesis in Taylor expansion form. Okay, but this time it worked, so good. Maybe it worked. Let's double check. Okay, yeah. Could I repeat that explanation? No, I really can't. Okay, make struct from proposal. Defines. Okay, fuck. So we have a variable bound to another variable in another thing, I guess. And I guess that's a thing. Maybe the solver should intercept that. Let's even, where is this? Prop. It's line BB 187 of okay. I mean, that's actually kind of straightforward. What is the generating call? Line 191. Oh, fuck. I forgot about this. But why do we... We don't actually need to make this anymore. Okay. Okay. This indicates that the cleanup is not finished. So what's happening is, because this is how we did things in the old polymorpher system, when you had a function and you said something like holder with some $sign variables, these happen to be called T and N, which is the same names here, but they don't have to be, right? These are just whatever names you want to use when you're calling this function. We used to actually construct the type with these things bound to these things, and it's one of these things that's confusing and hard to understand and you forget about and all this stuff, which is why I wanted to rewrite it. We don't need that anymore. We don't use that to solve this, but for some reason we are still constructing the type. So here's what I'm going to do, is I'm going to back off these changes for now. The two that, I think we can go the third change, and then we'll keep looking through this file. I think we make all the changes we can make, and then we leave these, and then we go figure out why this is happening. Why we're, well, I know why it's happening, but we go figure out what to do instead of this. And I think it might be very simple. But we just need to, like, that might be a whole ordeal that takes honestly a couple hours to do because it's a complicated compiler, right? But then if we do that correctly, it'll also have the advantage that it'll speed up this kind of polymorphing a little bit. Yeah. Yeah, and then we'll see. All right, yeah, that makes sense to me. I understand now what is happening. It is confusing, but oh my God, it's going to be so much less confusing. All right, so this, I was trying to replace this with a thing that meant something different. So we're going to put here pickle sector. We need to make stuff like the following. Not generate weird internal types for holder. Should not be hard. We'll see. And I'm going to put this in the to-do. And we are going to reinstate those. Okay, so all this stuff. This was an incorrect interpretation as well. Not pick sector, pickle sector. And then we return true. And we get rid of this condition A, condition B stuff. Now we want to try and clear pickle sector. If we can, we'll continue on in the file. Back up in the Weissman sector. I need a backup in the Golden Monkey T sector. That's what I need. That's what the pickle sector video game should be. It's like an XCOM game. Before they fucked up XCOM. Okay, so now we had one more no check-in. And we're going to see if we can put that one I feel like should not be problematic. Dang it. Even that. Even just that little change. Wait. Yeah, I don't know. I don't know. We're in obviously scary territory. So things that should have failed with user errors didn't. What? Well, here we go. Same thing. We're going to go bool condition A equals all right. Constants. All sorts of pickle sector. Death and destruction. That's fine though. We want that. We want that. Okay. So many fails. Almost everything. Almost everything. So let's pick an easy one. I don't know. Can we do like 001? Yes. Okay, should be easy. What just happened? I don't even know. Wait, what's it called? 001 first. There we go. Okay, condition A, false. Condition B, true. Source decal inferred type. Should be equal to this, right? First of all, yes. Oh, right. No. So what is it then? I think maybe we need another. We always could put a flag on this actually too, but okay, it's just a regular declaration with an inst. Where is this line? 291 of compiler. Oh God. I didn't. Fuck. This is actually not right. Lol. That's not right. This is going to be in struct arguments, right? So this function, yeah, this is where I just didn't think that much about what was happening. And this is where we may get easy sag. Easy sag. All right. What does this do to our pickle sector scan? Okay, we still get fails, but there are many fewer. Now the problem is, I don't know if they're that condition A assert. Oh, there's a lot. Or they're due to this other change. So we may have to comment out the condition A assert. Where are we at? Sometimes we're asserting. Oh, God. I think it's both now. Okay. Okay, guys. Sometimes concepts evolve over time, right? Concepts evolve over time. When, like, structs didn't used to necessarily have their own separate constants block, because I was like, oh, it's got an arguments block to give it the arguments, and when you supply the arguments, why bother moving them out of there into a different scope? Why not just leave them where they are and just bind them, right? So originally it was like that. Then I was like, wait, A, it's cleaner to have it work like other things. B, we want to make this clear to the user by maybe putting them in different places in the data we give to the metaprogram, although that's not necessarily a reason to change our internal representation. But C, there are other things that we want to go into the constant block that are not and never were parameters of the struct. So then it's really bad and weird and messy to use the arguments block. So sometime a while ago, this is probably more than a year ago, probably a couple of years ago, I changed it. But this function didn't change. And now we may be leaning on this function to check more than we would like. Okay, so for the meaning that I'm trying to use it for, is it an unbound constants block entry? That should literally only be checking block constants. Why did I let this slip through? Because it was already there and I wasn't thinking that hard about it, right? Okay, problem is some other code, if we take out this check, was probably relying on this check to like catch some things. And so like now we have to audit for that and figure out WTF and maybe break this into two different functions, right? Make it some other thing that detects these, because I don't want to keep this concept muddled together right now, if you know what I'm saying. So I want some chocolate and I don't have any. Sag. We're rewriting the renderer because you need to make a high performance game. You need to use a modern high performance graphics API, which OpenGL is not. And that is what we were using to date was OpenGL. You should not use OpenGL for real high-end things. You really shouldn't use it for anything, but unfortunately, people have not been very quick to supply alternate things. Okay, so what I'm going to do is I'm just going to be a Chicken Little here. First, I'm going to back this out. But there's a lot to be said for temporarily being a Chicken Little, or like, it's like Sun Tzu, fight on the terrain of your own choosing, actually. So we want to say, okay, so we need to clarify those. We need to break this into something else. We need to scan the program for who is using that. Okay. Now, the thing is, usually I don't like to divert from what I'm doing and go do other things. But what we're doing right now is adding more usage of this function. So what we're trying to do is analyze all call sites of this function to figure out which ones are causing problems. If we add more call sites, we're giving ourselves more work to do later, right? Now, I suspect, so the thing is, this was not called very much prior to this stream, I don't think. And so what I could do, so we're going to get back to clearing pickle sector, right? We're going to check in. And then I'm going to go look on my laptop at a 2 hours ago version of the code and see where this is called. And we'll try to determine, which of those sites is sus. Okay, so, all right. So here, we are back to this. We're going to put a pickle sector here, right? So pickle sector is everywhere that we tried and failed. They tried and died. Is the game moving to Vulkan? We're doing DX12. Fuck Vulkan. No, we might do Vulkan later, but Doom 2016 relied. Yeah, don't pick one example and from 5 years ago and base everything you know on that. And like, no, actually Doom 2016 was Vulkan, so you're saying the wrong thing anyway. You're saying the wrong thing sarcastically. I'd say it was pretty high end. It was Vulkan, dude. OpenGL is a poop. Just admit it. OpenGL was a good API back in the fixed function pipeline days. It doesn't make sense anymore. Just the entire way that everything works is nonsensical and annoying and confusing now. And it doesn't even give you high quality results. It's supported both, right? But like the actual good version of the game was Vulkan. Yeah. Casey said modern OpenGL past like 4.5 is decent. I'm not paying very much attention to what has happened lately. So I don't know what he might like about it. But the problem is it's super complicated now. Most of the complications don't have any good reason to exist. DX12 and Vulkan are super complicated, but at least they're trying to do things. The drivers are awful. The debugging experience is awful. And you still can't, like, I don't know. I'd have to look, before I say what you still can't do, I'd have to look at the most recent ones, but okay. Okay. Basically no changes. Oh, whoops. I left a condition A variable in. Oops. Basically no changes since last check-in, but that's how it goes sometimes. Okay. Okay. Now, all right. So now I had done some stuff over here too, but I think that we don't want any of it. It is superseded by what we have done on this stream. So what do I do here? All right. I am searching for who calls is unbound constants block entry. And there are some calls. There's about 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So how do we go about figuring out which one? Okay, actually, let's go back to a place where here's what we could do. Let's just do this. Because if we get here, right, we were going to return true, but we don't want to return true. So anyone who breaks here, which might be like literally every single program, it means we're returning the result we want. Like we could, for example, in the type table be returning a wrong result and doing the wrong thing, but it doesn't actually matter for most programs, right? All right. No, most programs are fine, but some of them are definitely being assaulted in pickle sector. What do you mean not really? You have to write completely different shader programs everywhere at minimum, right? And you have to write different interface code. I don't know. Like don't pretend that if you're going to claim that game developers don't already write completely different backends for their engine everywhere. You're just not keeping in touch with what games do now. It's a very bad situation, and we definitely should try to clean up that situation. But the clean up does not look like OpenGL. It looks like if you want something like OpenGL, a user space library that acts like OpenGL, but is user space and therefore customizable by user, if your pronouns are Zer. Okay, so yeah, we definitely are seeing this somewhere. It looks like it's, type info related, probably would be my guess. Simp example. We have so many choices of where to look. Oh, we're doing resolve constant expression to type or return null if we should yield. Okay, is it that? It's line 476 of const expert. Is that literally everywhere? Okay. That's strange. We return polyuse. Oh. Do we have an isstruct argument? No. Let's just break this off into two things. This is very weird because this didn't even, you can have something in the struct arguments block that has an expression, but it's not bound because that's just the default value for the frickin' argument. It's like, dude, oh my God. Oh my God. Becky, look at her butt. Is unbound constants block entry. You guys, you act like you don't know songs. Do you not know about songs? People in chat? Okay. Argumenty. Okay, has this improved our pickle sector situation? Is Sir Mix-a-Lot really that old now? I guess so. I mean, if nobody understands about Becky. Your colleagues don't like it. The point of vertically aligning things is to emphasize that several related operations are happening in parallel, right? You don't just vertically align anything, but it's like, oh, we're doing this thing and that thing, and it's sort of the same thing twice, right? So you're communicating that it's like the same thing twice or the same thing 4 times or whatever by aligning things. If you're calling 2 totally separate functions, I wouldn't vertically align those. You know what I'm saying? But or assigning. So one case is calling the same function with different arguments in a row. Another one is just assigning to different members of a struct, right? Just like line it up. We're filling out the struct. Filling out a struct is sort of like one statement, but it's broken into a bunch of statements, but you make it look like one thing. What API does PS5 use? It uses the graphics API that the PS5 uses. Hey, look, pickle sector is now clear. So that was like literally the only place, as far as I know. Okay, so this means we could get rid of this. You have to sign an NDA. Oh, you really have to sign an NDA to make a PlayStation game or an Xbox game. Oh my God. Such NDA, such wow. Such mega wow. What? What are you even asking? Okay. Now let's go back to where we ran away from, which was here. This third pickle sector, I think we could do this one now. Let's check that. And that would mean we actually made progress. Boom, pickle sector is clear, over. Roger that, control. Okay, so pickle sector is now clear. Okay, let's reconsider some of these now. So these we decided were a different scenario, so we cannot touch these. But we can look further down the file. So this is a type. I think that this can just go. I don't think we need that. Oh, except we do need it till we get rid of the thing. But that's okay. This is like, this is going to be a pickle sector, which means we saw it and we know about it. It can go away once we change the thing. All right. Here. Wait, no. That's not right. Hold on. No, it is right. It is right. Okay. Status wanted dot matches. This is in the middle of our solver. And we say, if we define constants block entry, was matched directly to another polymorph variable. Okay, this one we want to get rid of, but I think that we want to catch it in a different way, because this is an important user-facing error to catch. And so we want to move where it's being detected and then make a test case that repros this. And so that's not in this first pass operation where we just look for easy claps. That's for later. But what we're going to do is, do a thing where, yeah, I think that's going to be easy to detect. Okay. This one. Okay, this is the last one in the file, and we'll probably do a check-in after this. Here's what I want to do. I want to change this to expr equals type def poly use. Let's see if that works, and if that works, we can then try one more step on there. Is DX12 slightly higher level than Vulkan in terms of synchronizations? I don't honestly know. Don't honestly know. Pickle sector is clear. So we're going to go we're going to call that shizzle nizzle. And we're going to scan again. Scanning. Scanning. If only who would have stopped. What are you talking about? Once Upon a Time in Hollywood's a good movie. Okay. So one more minor change. We do this. We do this. We do that. And we scan again, and then we check in if that works. And then we made a little more progress. Slowly won progress, but good. Look, if you don't like Once Upon a Time in Hollywood, it says more about you than it says about Once Upon a Time in Hollywood, all right? That's all I got to say. That's all I got to say. Okay. Pickle sector is clear. Small progress, removing defines constants block entry. Good on that. Now, well, let's go back here. We're doing a search. Whoops, defines const. Oh, we still got some of these. Okay, so now all of the ones in polymorph are like, those are for pass 2. These ones in matching are for pass 2. So we really only have this many to look at to finish pass 2. Wait, I thought we did type table. Oh no, because type table, that's also pass 2. So it's literally typer here. Okay, so here, this is a pickle sector. Again, it's confusing, but this is not the thing that we're looking for. This is when we're bound to the fucking thing. So we're going to have to deal with that instead. Okay. So here is when we decide if we're going to invoke polymorph solve to type check arguments. Okay, so I kind of don't understand why we're setting. So if the given type is polymorphic and it's not polymorph or it's not polyuse, I kind of don't understand exactly what's going on here, but I think we need pickle sector on here as well. Yeah. Yep. Here. I think we can get without that. Find constant replacement, import link. I don't think this could happen. Let's find out. Whoops. Lol. Lol. Okay. So that gone. This is gone. We're just going to run another one. That won't have changed anything, but we're just being cautious because we're in perilous territory. While that's running, we'll look at the next one. And again, this will not have any equivalent this type, but okay. I think we do this. I think we say I think we do that. Okay, pickle sector was clear prior to this change. Well, let's see if we messed it up. Rick Sanchez. Type mismatch, type wanted, type given, unknown. Dang it. Dang it. Dang it, dang it, dang it. Dang it, dang it, type wanted, type given, unknown. So I don't know why this causes that. So it's printing unknown because we earlier in the stream we deleted the thing that knows how to print this out. All right. Do 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 do. Do 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 do. Okay, so we did do this part, and pickle sector was clear after that part. So I mean, maybe we do something else further down. I really don't understand what is going on here, but it might not be important to understand, right? Maybe because all we're doing right now is we're doing this first pass to make the hard part easier and less confusing. And like, you know, if this is confusing, we can just wait. Because the fact is, we're not going to generate these later. And, well, we're not going to generate these. And so, if the thing that's going wrong is the way that we handle those only, it's going to become irrelevant, right, later. So we're just sort of doing an iterative process where we clear in each pass things. So we're scanning. Finish the project and release it on Steam. Well, good job. Good job. Like if you actually finished, that is cool because a lot of people would not finish. Whoa. Wait, what? Okay, now we're kind of in trouble. Oh wait, I commented out the wrong frickin' thing. I put a pickle sector, but I meant to pickle sector this. And I did a badge. You were in charge of networking. Well, good job. I bet you learned a lot about networking doing that, right? It's a good way to do it. Can you plug it? Yeah, it's fine. You could post a link or whatever. Yeah, it's fine. It's fine. Okay. This is excellent. This is excellent. Defines constants block entry. Okay, we have 3 more in this file, and then we're done with this pass. So what are we doing here? If it's a type valued expression, and it's not a lambda, I think this is a pickle sector because this is just going to go away. But again, we're still putting the content into the stream. Okay, how about this one? If it's got an expression, okay, this is definitely a pickle sector. This is like some of this crap up here. This whole comment is going to go away, hopefully, and this will go away when that gets figured out. Okay. So we're putting lots of pickle sector down, but that's okay. So now here, what is this? This is also a pickle sector. All right, well, literally, we have that much left, which is about half of what we started with, which is more than I would have liked. However, it's fine, hopefully. Hopefully. Let me do one more thing, which is I'm going to rename a function. Here, we're going to say, instead of attach defen to, we're going to say designate as, because we're going to change, we still need to call this function, but we're going to change what it does later. So I just want to get that in now. And we're just going to recompile and test, and then we'll check in. And then we maybe get to the hard parts. Yeah, I mean, you know, if I say something's hard, it doesn't mean you can't do it, right? It just means be ready to do something that's hard. That's all. Like, don't underestimate, right? A lot of times people underestimate problems. You feel like if you redid it now, it'd be easy. Yeah, like lots of things are that way, right? You just get better at it and you understand things better. And then you're like, oh, yeah, it was so stupid that it took me so long, right? It wasn't really stupid. It was just like you didn't know, right? But that also means that the next time you do one, not only would it be easier to do the equivalent of what you did already, but you can do it at a higher quality level, right? You can aim higher in terms of results. And that's just the magic. That's how you get better at things. And you just do that again and again, and you get better and better, right? That is how it is. Okay. More work on removing. Okay. Now is where we start doing the things that may make us sad. All right. This is where it could get rough. And what I'm about to do, we may just end up reverta Williamsing. And I'm tired, but we might play more bad video game tonight because Pickle Sector ain't going to defend itself. But what we want to do here is just get rid of this. Because this is the thing we're trying to get rid of. We want to delete this struct member, but we're not quite going to do that yet. And this thing in ident. Wait, I thought. It was this Pickle Sector that I was looking for. Actually, you know what? Before we do that, let's even see if we could just do this. Add that thing to ident, and does it break things or does it not? Because it broke things when we swapped that other code. But if I just add this, are we okay? Easy clap. Okay. That is cool. So what about this? This is very likely to cause a big problem. Like, if anything even compiles, it's only because of that code change that I just did. Okay, yeah. Massive slaughter in pickle sector. It's like the battle of the line. Just everybody getting destroyed. We expected no less. We expected no less. So we just need to see what these guys are breaking on. And Visual Studio is so bad. Okay. So we're just going to break here or something. All right. Stuck pipe. No, pipe. Okay, there we go. Input 96. Damn it, bro. Okay. Let's go down to print cycles. We need to narrow this down a bit. So we're printing out a line. So log, for example. Log depends on the body of the header of log probably, which depends on print to builder. So like we're sticking. All right, so what is this? It's a lambda body. I'm going to guess that we're waiting on the header. Sleeping. Let's actually go to the next one. To the next one. Okay, this is going to be the header. Wait, what? Hold on. Wait, what? Okay, this is I is 0. Node queued is FF0. 2, it's a different one. But oh, it's the body of log waiting on the body of a different log, like they're overloads. Line 414. Okay. And then waiting on line 431 on 991. Wait. What? Log error. Oh, I was confused. Guys, I was confused. Okay, never mind. So these are all bodies waiting on each other. I just saw the word log, and because I'm tired, I was just like, okay. So the question is, like, why is a lambda body waiting on another lambda body? That's pretty weird if you ask me. Oh, it's because we consolidate the nodes. That's why. Okay. Node queued. I have to sort of decode this a little bit. The header, how's the header doing? Header was fine. All right, so this thing then, we yielded on lambda body. Like, why? Oh, because we're waiting on okay. So it looks like we're yielding in our known callee list. That's the only thing I see that's non-zero. This is probably where we set it. So none of these guys are getting through the run pipe. That's in pipe run. That's in pipe run. That's in pipe run. Okay. So what were we looking at? No, wrong window. The known callees. Okay. I kind of don't get it. These are all in the run pipe. It's pretty weird that you know, my brain is a little bit fading because I didn't get enough sleep last night from playing video games late. So we might just call it at this point. Because this is going to be just a little bit of a debugging session where I try to figure out why these things are stalled in the compiler pipe, which is not that fun. Let's look a little bit more. I'll just wake myself up a little more. But like whenever I start doing this, it's like, oh, the energy is ebbing. The energy is ebbing. Okay. I mean, if I am sus about something, it's the middle one, which has all the frickin' known callees. But that, you know, let's actually... It's kind of beside me. I don't know. Like, why are we not cycle breaking this? Yeah, this is all fine. I don't see the problem. Obviously there is one. I think the problem is something super dumb. Like, let's just. I bet that stalls, right? Yep. Oh, it's stalling in default meta program, probably? Wait, really? So, like, what if we give it a completely empty program? Yeah. I think default meta program. No? Who imports print? Then there's no print here. Or basic. Why am I so confused? Oh, default meta program imports something that imports it, I'm sure, right? Like import. Oh, it imports it at the bottom. I just searched for the wrong thing because I'm tired. Okay, yes. So literally nothing will compile right now. Unless I take that out. So this is not polymorphic. Log error is not. And print to builder is not. Wow, Emacs. Go, Emacs. Where are we on the Weissman scale? 84617. This is likely to be our final Weissman score for the evening. It didn't go down drastically. It'll go down more when we get the full thing done. So this was not as dramatic a Weissman drop as yesterday, but, you know, mildly meaningful. Mildly meaningful. Well, yeah, all right. We'll take a look at it later. Cuz I'm sort of two minds about how to investigate this. I could write a little bit of a visualizer or something. I mean, there's all sorts of weird things that could be going on. I don't even know if that cycle that's being reported is really the problem, or maybe it is. Let me give, I need to, so sometimes you can get a little more information to feed your subconscious about thinking about the thing. So this one, the one in the middle is, I mean, we can tell from running the thing, right? It's log error, line 431. Actually, doesn't it come out differently sometimes? Maybe it does for a different program. We'll verify. This is line 431. Okay. Oh, it's not the one I was looking for. Okay. Yeah, they do move around sometimes. Okay. It's this one that has 7 known callees. It's likely that one of these is the problem. And I just want to look through these real fast. Like the data is not, you know, like I wish I could see it better. But, okay, well this thing is still in the infer pipe, which is a clue. That's got a using in it. Oh, string builder has parameters, right? No, it doesn't. Okay, well, where's that blocked? Let's see. It is blocked on line 50, or not line, but expression 53. An identifier. Okay. What is the identifier, please? Min. Oh, min is polymorphic. Okay. Okay. Wait. Are polymorphic functions just not passing? Because their declarations don't oh yeah, maybe let's see. Min right. Got to cast this to declaration because I make bad life choices. Expression is a lambda. This lambda will be stuck, probably. Yep. And it is stuck on... Oh, probably because the thing just doesn't get a type. Is literally the first thing. This is going to be a declaration in the constants block, right? Oh no, it's another ident. Okay. No. How we doing? It's T. Yes, okay. So this identifier is resolved scope entry. Okay, that's weird because I thought that thing that we just pickle sectored would take care of this case. So what I want to know is, why does it not? Actually, let's go. Oh, because yeah, hold on. Maybe I know this. Maybe I know. Because if we look at this, I bet this also Mm-hmm. Mm-hmm. Why don't we just... What if we just do this? Oh, you know what? I was very smooth brain because I didn't even think about the fact that we were setting the type before. Now we're not. I was assuming that somebody else would infer the type in the natural process of things, but we probably don't do that. Hey, look. I don't expect everything to work, but maybe it will. Nope. Okay, we got some errors, but vastly improved situation over what we just had. Okay. You know what? Okay, the conclusion that I'm coming to is we could do this. But I don't want to do this yet because what I actually want to do, remember before there was some stuff with like error messages where I was like, okay, wait, we need to change the way that error is detected so we can preserve the error while deleting this thing. I want to do that before I do this because that may have an impact on this, I think. Binary operators unhandled in bind definers. Yeah. We've got some things to think about. But okay, this is good. This is a good step. So here I'm going to put pickle sector. And this is where we're going to pick up later. And I think actually I'm not even going to play bad video game tonight because I am really tired. We're just going to let our winners ride. Okay, this is good. I had hoped that we would actually blaze through all of it, but sometimes things are not as easy as you wished. But it's no surprise because what I'm doing here is getting rid of a bunch of stuff that's been in the compiler for years, like probably 5 years. So we didn't get rid of all of it in 2.5 hours. That's fine. We'll get the rest of it. So next time we start with that error check, and even just moving that error check will be good. Yeah, okay. There's two big things. One is moving that error check, and then two is changing that representation of the confusing thing about definers being polymorphed and stuff. And when that goes away, that can go away before we remove the rest of this stuff. And when that goes away, that probably removes the requirement of some of this other code that we had to leave in, because we won't any longer be generating those data structures that code is required to detect. And then I think most of this goes away in wave 2. And then this thing that I was just trying to do, where I just like shut it off, that's actually maybe got to be wave 3. In fact, now that I think about it, I'm totally not surprised that it doesn't go yet, because that wave 2 stuff that I mentioned requires the data to be there. And if it's not, yeah, okay. I was Sag. All right, so we are gonna check this in. I'm gonna say small progress, and I'm gonna sign off for the night. But thank you everybody for coming by, and we'll probably stream a little more of this at some point. Maybe not. Maybe I'll just do it on my own time. You get the basic idea. Like, this is, we're cleaning up things that are messy, and it's not always the most glamorous thing to do. It's not always the biggest, like, showy thing to do. But you know what? It's the difference between your thing slowly sliding into chaos over time and actually being usable, tractable, and reasonable. So you got to do it. All right. Thank you, everybody. See you later. Have a good evening. Good luck in your projects and whatever you may be doing.